And welcome back. Now, this week we're going to be looking at ESP32s as a potential solution for my workshop heater problem. What's that? You're not aware of my workshop heater problem? Well, it precedes even my current workshop in which I have the aforesaid heater. The problem is this. I have a heater. It's a 2 kilowatt-ish standard convector heater. So there's no fan in it or anything. It just blows. Well, it doesn't blow. It just lets hot air rise through it. And it's on an independent circuit from the consuming unit, aka the fuse box. And yeah, it works great. Well, I say it works great. It's got a bimetallic temperature switch inside, which is, as we all know, it's sort of a bit, rough and ready, isn't it? The hysteresis between the on and off is probably a bit large, but that all aside, it does work well. It heats up my workshop, no trouble at all. Except, of course, when I leave my workshop and I hit my kill switch by the door, I usually forget to turn off the heater. What happens? Yes, it's on all night, wasting power, and more importantly, wasting money. And, of course, there's the risk then that something bad could happen with it. So we need a solution that will enable me to turn off my heater at the appropriate time. But also we want a few bells and whistles. After all, this is an Arduino channel, isn't it? We just don't want an on and off switch, which of course is the most simplest solution yet. Let's think about a few things. I want to do a shout out for Jlcpcb. No, stop, don't go away. Look what they're doing. $2 for aluminium circuit boards. This is absolutely incredible. If you've ever wanted to try an aluminium PCB, now's the time to do it. Now remember, aluminium PCB is a single-sided normally with the aluminium on the bottom. Then you have a dielectric layer that transfers the heat up to the top copper layer. Now aluminium is very, very strong and it will suck the heat away out of your components without the need for extra heat sinks, for example. Go and have a look at their website and check them out. And there's more. Jlcpcb now allow you to create your own parts library, because there's nothing more disappointing than creating a PCB and then finding you can't get the parts or there's a big long delay. Now you can create your own custom parts library to ensure you get the components you need, and of course the associated footprints, so you know they're going to fit on the PCB itself. To get to this page that describes everything you ever need to know about creating your parts library, simply go to their homepage and then click on the link at the top. Very, very simple and a really, really useful feature. Go and check out Jlcpcb now. Let's think about a few things. So the absolute simplest solution would be to add another switch underneath the kill switch that you can see there on the wall. That big switch there with the red button on it. That is my kill switch and turns off all the power in my workshop apart from the essentials like my computer, which runs 24/7, and a couple of other bits like the Wi-Fi. But most other things like soldering irons, hot air guns and everything else is all switched off. They're the sockets that you can occasionally see in these videos that are above my workbench. But the heater circuit is on a separate one, and I could easily run a wire from the existing heater socket, metal clad socket, up to here and have another one of these switches underneath it. Identical in every shape and form, so when I leave the workshop I could switch both off. Job done, finished. Well, that was a quick video, wasn't it? What's that?
Where's the bells and whistles then?
Oh, you want to... Yes, exactly. Arduino channel. Well, I say Arduino, all things microcontroller. We want a more sophisticated solution, don't we? Than that. Okay, then we've decided upon a more sophisticated solution, which involves some sort of microcontroller usage. But let's have a look at what my actual heater looks like without anything doing to it whatsoever. Right, so there's a picture. And that's it. I mean, it's a resistive element in a metal case with a bimetallic switch, which, as I say, works well enough. I've absolutely no idea how accurate it is. In fact, the way you set the temperature, rather than looking at the dial, which doesn't really tell you the temperature, you think, yes, it's warm enough, or I'm a bit cold, I'll turn it up a bit. I mean, that's how it works. Okay, so this should be pretty easy to control, shouldn't it, by some sort of microcontroller. Let's have a think about potential solutions then before we look at actual hardware. Okay, let's have a think about what we're talking about. And there's the heater on the screen there, as we've just seen. That's great. Now, if we bypass the metallic strip inside, it would look like that. The neutral coming in on one side and the live on the other. Or it might be the other way around. Doesn't really matter, does it? When I say bypass that switch, what we can actually do is just turn the switch up to near maximum, so it's always on. and that'll have the same effect. Let's think now about the actual microcontroller unit. Yes, now what do we want this to do? Well, one, if it's going to do anything intelligent, it's got to do it wirelessly, hasn't it? I've got to be able to communicate with it somehow. So that's the first thing. It's got to have a wireless element to it. Obviously, it's got to have a temperature sensor, otherwise how will it know when to switch the heater on? Okay, yes, we do need an override button, I think, so that if I'm sitting here and I just want to say on or off, for whatever reason, I can do it. But more importantly, I can do that remotely via the wireless system as well. So I can just go on. We'll see about adding a little bit of intelligence into that sort of mechanism later on. Real-time clock, I've said here. Yeah, I said built-in as well in brackets underneath. It would be nice to know, and it could be essential to know, what time of day it is. So real-time clock would enable me to say, I can have a schedule. I can say, come on at 7 o'clock every morning, ready for me to turn up about 7:30, and it'll be warm. And switch off at, I don't know, say 6 p.m. regardless, yeah, even if the temperature gets cold. But more importantly, if it gets cold overnight and it drops down to say 10 degrees, it goes, I don't care that it's 2 o'clock in the morning, I'm switching the heating on for a bit. Yeah, so all that sort of stuff can be done intelligently if we know what time of day it is. Great. Yeah, obviously we'd like to know the status, so some sort of indicator on whatever it is I've got this built into. Oh yeah, and finally, of course, we do need a power relay. And by power relay, I mean something that's going to be reliable and being able to switch. I think it's up to 8 amps. So 8 amps is what that heater is on maximum power. It's got 2 settings, low and high, which I'm probably not going to try and control each of those settings electronically. You just have it on or off, I think, on the high setting. But it's got to be, this has got to be reliable. We don't want any fused contacts. I'll probably put some kind of snubber across those contacts as well, just to stop the arcing that over time will kill it. So basically that's what I'm looking at. How does this help me then if I leave the workshop, turn off the kill power, so my workshop goes dead, most of it, but I forget the heater? Well, not forget it, I deliberately leave the heater. How does this know that it's time to switch off the power? Well, this is when we come on to this bit over here, the wireless heartbeat, not since I've said sensor, but it's really a transmitter. So somewhere in this workshop there'll be a little tiny unit plugged in to the kill switch power, and every so often, and it doesn't matter how often, yeah, it could be every second, yeah, it could be every minute, it doesn't matter. It just sends out a signal to this one here wirelessly and says, I'm still here. And this says, that's great, because I'm just going to continue doing what I'm doing. The minute that doesn't happen, so this communication is lost, and this is now convinced that there is no more signal, this says, you've left the workshop, you turned off the kill switch, I'm going to turn off the heater. Simple as that. Yeah. So this could be quite simple in the sense that it doesn't have to be a dual core processor or anything. All it's doing is sending out one little thing to probably some kind of web interface on here that just sets a variable. Okay, that's nice. And then finally, it'd be nice, although I've said yes, we can have an override switch here manually, I'd like to override that with something like a mobile phone. So that as I'm getting ready in the morning and I think, right, I'm just making my breakfast and all that, I want to go out soon, I can fire up the application on my mobile phone and say, time to switch on. And this goes, oh, okay, I'm on now. It's sort of overridden here. I don't know, is that right? Is that the right expression, to override? It's not really. It's sort of a go command, isn't it? It goes, yeah, it's about right time of day and you're telling me to go, so I'm going. On it is. So by the time I get in here, it's all nice and warm and lovely. It would also be nice, but it's not going to happen straight away, is for my new Variac controlled fan, which is up there. That one works beautifully with that Variac, by the way. But there's a much longer story than the Variac for that fan, but that's for another video. It'd be nice if I could also switch that fan on at the same time, because what that does is blow the air around my workshop rather than having it concentrated over that side where the heater is. We have to bear that in mind, I think, whilst we're designing this bit so that this can perhaps send out a signal to something else to say, oi, fan, go. Okay, so that's generally my thinking. Microcontroller then, what we're going to use. Now, choice of microcontroller then comes down to something that has wireless capability, not something that we've got to add wireless capability onto. So that discounts really the Arduino and Nano and all that, even though they'd be more than capable of doing what we need to do to control a simple relay. But I'm thinking, okay, what processors have we got that would satisfy that, without going off-piste a little bit? Well, there's two that spring to mind. The ESP8266 and the ESP32. Whilst they're from the same stable, if you like, they are quite different though. Now the ESP8266, if I bring this little unit over here, this is in fact the prototype unit from my mum's Home Alone project. What is my Home Alone project, you ask? Basically, this PIR here detects when there's movement in her flat in Stuttgart, some 800 miles away, and logs the fact to the internet, ThingSpeak actually. There's two of these units there, and they both talk to ThingSpeak, which means I can have a little app on my phone that I didn't write, it was a freebie, and I can detect that there's movement and everything's okay. Because if there were no movement for any length of time, this sends out an email to me and my brother and his wife and all that to say, I think you better check up. And yeah, it's been very, very useful, and it's been running now for like 3 years solid, something like that. Brilliant little device, though I say it myself. I'm not trying to brag here, I'm just saying it was well designed and works well. So this is the ESP8266 D1 Mini. Well, not that bit, isn't that's an SD card that I'm using. The actual device is in here. Well, I would give you a closer look, but I haven't got another one. That is my only one that I've got left as far as I can tell. But anyway, as you can see from here and here, all these little D1 compatible components plug into this base unit. So from that point of view, I have experience with the ESP8266. I'm happy with the performance. It doesn't hang. It just works. It's a good solution. But even now, if you can see, look, there's a triple in there. That's triple base. And already it's starting to stack up and it's getting a little big, isn't it? Bearing in mind that this white thing over here, which is a standard UK double socket back box or pattress, it's got to fit in there. And well, I'm getting a feeling this is going to be all a bit of a tight fit. So I'm not quite so sure about that at the moment. Now, the obvious alternative is an ESP32. It's not something as large as this. This is what runs in my ESP32 web radio, and it's got lots of memory on it and PS RAM and stuff like that. That is just ridiculously large, and yes, it would fit in there on a PCB, but it's overkill. We just don't need all the facilities this has, and in fact, it's even got as an SD card reader there, reader-writer. So we don't really need that, but I quite like this one. Now, this one's a D1 Mini. No, it's not. It's a Esp32 Mini, Mini 32. You can just about see it there, look, V1.00. I'm always a little bit hesitant about V1.0 stuff, but this seems to work all right. Now, you notice the LED that I've stuffed into those two sockets on here. Yes, I soldered these headers on at some time in the past. I must have been experimenting, I guess, with long headers on one side and short on the other, because it's ESP8266 D1 Mini compatible in footprint and footprint only. So I think you can use like that mini screen and all that. I think you can plug those into something like this. Yeah, it's not for me this time, but anyway, it's the D1 Mini. I've got another one of these without all these sockets and things soldered on, so they're quite low. Obviously would fit into here quite nicely because it's quite small. However, one of the things I hate doing, and I'm sure you do too, if you plug in a USB cable in here, but to upload the code, well, you've got to constantly press one button and then another one, and then you release the first one and then that one, then you've done it too soon and it goes, oh, I can't sync correctly. Yeah, we've all been there. We've all been there. So I thought, I'm not going to use this if I have to do that. I just want to plug in the USB cable, as I do with an Arduino, and it just uploads. So if I can get the blink sketch on here without having to press any buttons, I think we're on for a winner, don't you? Oh, and look at that, blinking in all its glory. Yes, all I did was plug in the USB cable, loaded up the blink sketch for the ESP32. Well, I modified the existing one, told it to output on D27, so that's the outside pin there, and the ground is right next to it. And look at that, straight away, no issues at all. So that makes it a nice contender for what I need to do. Okay, let's see how it's all going to fit into this little unit here then. So this is a standard UK back box for a double socket, and on the front of this I'll simply put a blanking plate, and into which I can drill holes and things for LEDs. And as you can see, there's lots of room. This is a relay, not the one I'm going to use because it's not high power enough. This one says 7 amps at 240 AC. Well, 7 amps is not 8, and I wouldn't be pushing it that hard anyway. Even if it said 8 on there, would I want to use it? No, it's at the end of its extreme power capabilities, isn't it? So no. So I'm going to use a different relay, but it's not going to be hugely different to that. And then of course this unit here. Now the mains will be coming in down the bottom to be switched by the relay. So that's it, isn't it? We can use the mains directly to power all this, can't we? So here's a nice little circuit. Look, for a capacitive power supply, which means we don't need any transformer or anything. So over here we have the line input. We have a Zener voltage here, 5.1. Actually, we don't want 5.1, we want 3.3, but there's a power LDO on that board, so it will drop it from 5 to 3.3 anyway, so that's okay. Reservoir capacitor, D2 to stop this discharging. Here's the crux of it. This is the capacitor. Now it says here 0.47 microfarads, 250 volts. Not in the UK. That might be okay for the States. We've only got 120 volts, but this has got to be well above peak, not just RMS. So we'd use something like 450 volts in the UK, even 600, quite frankly. These are the capacitors you find in ceiling fans to slow them down, and they work very well. That's the subject of another video. And then we have a dropping resistor here. Well, I say dropping, it's an inrush resistor here, 470 ohms, half a watt. And yeah, it says here, look, it limits the inrush current, and it doesn't dissipate that much heat actually at all. So we get like the power for free, don't we? Mains in, power out. What could possibly go wrong? What?
Dangerous, surely.
Dangerous? In what? Yeah, okay. This is dangerous in the extreme. It works, and believe me, there are many, many, many commercial bits of equipment out there that do just this, but of course they're sealed units, not meant for prying fingers or Arduinites to go in with their test probes and oscilloscopes to find out what's going wrong. I can't think of anything worse. This is very dangerous unless you really, really know what you're doing. And you're thinking some cowboys developed this circuit. Yeah, I know. Let's see who actually developed this, shall we? Oh, there. Oh, it's Microchip that told us to do that. Look at that. Now that's an interesting thing, isn't it? When I first read it, in conjunction with how to control my workshop fan up there, this popped up, and I thought, oh, that's interesting for a future video. Perhaps I can use that. So Microchip are saying we can use that circuit to power up its chips, and with a few caveats. Basically, don't kill yourself, know what you're doing, and you can get away with not using a little tiny transformer power supply, an isolating transformer power supply. Interesting. And yes, it would work, I'm sure, and lots of products do exactly this. I'm not going to. So, yeah, come down off your soapboxes, everybody who's going to say don't do it, because that is very dangerous to use that. And it does tell you that. It does tell you that in its write-up. And that's the warning that it has plaster all over this thing. Basically, an electrocution hazard exists. Really? Do you think? Yeah, no transformer for power line isolation. Oh, really? I didn't notice. Yeah, an isolation transformer should be used when probing the following circuits. Absolutely. Now, as it happens, I'll show you what I use when I have to go into mains power supply, because I don't want my oscilloscope to blow up. And if you remember when I did the video about my fan controller with the Variac, I said I'm not going to put my oscilloscope on it. And then I decided, well, actually, I can put the live on it, just the tip of the probe, but not the earth, because I don't want the earth shorting stuff out. But what I could have done, which would have been a better solution than what I normally do, is to use one of these. So this is a mains isolation transformer, and its only job is to accept the incoming main supply here and send out another exact same equivalent voltage main supply out here, but in the middle there's a whopping great transformer, and this is big and it is heavy, right? And I keep thinking I should really bolt this down to a piece of wood and have sockets and things, but I don't use it that often. It just gets in the way, and being so heavy, it's not something you can just sling around the workshop. Now on this particular model, it's got 215 volt outputs. Does it ever say? No, it doesn't say anywhere. Okay. Oh, hang on, here we are. So the secondaries are 2 times 115. The input though is 200, but it says 230 because that's what the official voltage is in the UK at the moment. It's actually 240. The reason why everywhere says 230 is so that we could harmonise with the EU, even though we've left now. It's 230 plus or minus, I think, 10%, so we went well within that. And the secondary, as you can see, it's only half an amp. It's not a lot, well, less than half an amp. You simply put these in series to get your 230 back out again. Great, so that's what I would use were I to use that circuit from Microchip and power that circuit up without any kind of isolating transformer. But we're not going to do that. When I repaired my workshop heater unit, in that video there, look, basically the heater failed. I can't remember exactly what the fault was now. I think it wouldn't go on anymore, just went off all the time. Anyway, I took out the control board, the printed circuit control board, figured out how it worked, and put in a strip board with an Arduino on it, a Nano actually, and ran it from that. I was a little bit nervous using all that mains electricity around it, but it works and still works, and it's sitting under my workbench ready for the colder months of the year later this year. That worked fine, but to power the Arduino itself, the Nano, I thought I can either go the route of the original PCB and use that exact same circuit from Microchip and power it directly from the mains, or I use something like this. Now, the one I used in that workshop heater repair was a slightly different version to this, and there was a little bit of discussion about whether that one was safe or not. And I said, well, only one way to find out. So I used it, and it's working fine at the moment. But this, I think, is a better version. It's certainly got a lot more feedback and reviews, and people are saying this actually does work very well. So I'll be using this. You have AC input over there. So you get 240 volts or 120 because the input is, quite wide range, isn't it? And the output is 5 volts at 5 watts. So you get a whole amp out of here. Well, I don't need anything like an amp to run this. I probably need 200 or 300 milliamps tops for the ESP8266, and when the relay's switched on, I probably need something like 60 to 100 milliamps to turn it on. Now, I've been through my little box of relays here, and none of them are suitable for what I need, so I'll have to get something else. However, if I'm going to drive a relay from 5 volts, which all these here do, it means I'm going to have to take the 5 volt supply that is also supplying the ESP32. I'm a little bit hesitant about that because the current required by that relay, because the voltage is so low, is quite high. In fact, I worked out that the relay that I need has a coil resistance of 36 ohms, which means it's going to require 138 milliamps to pull in, which is, okay, the power supply that I'm going to get, something like this, would supply that no trouble at all. But given that it's going to pull 138 milliamps from the supply that this is using, I don't want any brownouts happening, and I don't want to put in whopping great electrolytic capacitors to prevent it either. Now, if I were to use a 12 volt relay instead, which I haven't even got, a 12 volt relay, which would have a higher coil resistance, in fact the one I'm looking at has a coil resistance of 200 ohms, that means it only require 60 milliamps. And of course, the good thing is that the 12 volt supply from one of these is not directly connected to the 5 volt supply that's going to eventually connect up to one of these pins on here. So that gives me a double bit of safety in it, if you like. One is that the power supply that I can use will be a dual power supply. It will give me 5 volts on one pin, 12 volts on another, a common ground, and they're both regulated supplies. The 12 volt supply on the power supply is lower than on the 5, but it's more than enough to supply that 60 milliamps for the relay. And the 5 volts, which will go into here, is, I don't know, half an amp or something, which is plenty. Now, the size of it is still about this size. So what with that in there, and that in there, as you can see, there's still plenty of room. And if I get a simple PCB made up, where all these things are on, and we'll keep the mains incoming supply well away from everything else, you know, have proper spaced and soldered up tracks, possibly with some kind of air gap in it, exactly as I did really with the workshop heater repair, I think we're going to be good to go, frankly, and it's going to be quite an easy little project. Well, the hardware is going to be easy. I think the code is going to be somewhat more difficult. Yeah. Right. If you like this video or you think you've learned something, please do give it a thumbs up. I'll be really interested in your comments down below, you know, suggestions on how you'd approach this and whether I'm on the right track, because I'm about to order some of this stuff. And don't forget, if you're going to subscribe, and I really hope you do, don't forget to subscribe and tick the notification bell, otherwise you'll never get told about new videos from me. Okay, great stuff. Yeah, I know, YouTuber nagging me to tell you that. Okay, that's it. Thanks very much. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.